What I'm going to do is go through the multiple choice questions from the SAC so you can follow with me. Please have your calculator, actually do these questions, stop the recording if you need a bit of time to catch up. So for question 1, what I've done is define that curve and I want to find the stationary points. So I'm going to find a derivative of the function f of x with respect to x, and then I'm going to find where that is equal to 0. For x, and it tells me -7 and -1, so that's option E. Let's have a look at question 2. The trick here is that it's an absolute maximum. So if I was to draw that graph, which is x minus 4 squared plus 20, I can't see it, so I'm going to do menu for A, and it's going to give me a zoom fit. So I could find the values, but at the moment I need to make sure that I've restricted my domain, because if you look at the domain in the question, it goes from 0 to 10. So let's do that. And now we can see our minimum is going to be down the bottom here. I'll analyse for a minimum. So the smallest value is going to be at 20, and the largest value, well, it looks like it's going to be at the other end at 10, at the other end of the domain. So menu trace, graph trace, 10, and 10 goes up to 56. So the minimum is 20 and the maximum 56. For question 3, I'm going to define my function a of t to be square root of 3t plus 9. The rate at which it is growing, so that's the derivative. So menu, calculus, derivative. I'm going to define with derivative with respect to t of a of t. After 3 months, what's this? So I'm going to copy that down and then go, given that t is 3, that's a half, so the answer is B. Question 4, I'm not going to bother defining this because I don't need to use it again. So I'm just going to find a derivative of, with respect to x, 1 over the square root of 4x minus 2. So that's a little bit weird looking, but you see that is the same as option D. Heading across to question 5, we went through one of these in class. The average rate of change is the gradient. So if I define my function f of x is 3 times 2 to the power of x plus 6, the average rate of change between 0 and 2. So I want rise over run, or y2 minus y1. So f of 2 take away f of 0 over 2. 9 over 2, 4.5, option E. Question 6, we know that if we have f of x is minus x squared plus 4, I'll actually put that in, minus x squared plus 4. Let's find the derivative of that function, and it's minus 2x. So we know when the tangent meets the curve, it has equation of y equals minus 2x plus c. This also has a minus 2x. So we know that the gradient of this curve, or dy dx, is going to be minus 2 when x equals 1. When x equals 1, what is y? Well, for the original, if we put 1 in, we get that y is 3. So I'm going to solve y equals minus 2 times 1 plus c for c, and c equals 5, option E. Let's look at question 7. That's not a calculator one, so I'll keep moving on. Question 8, the antiderivative. There's no problem here. That's the integral of 2 divided by 5 times x to the power of 5 on 2 with respect to x. 4x to 7 on 2 on 35, option E. So that's just a calculator question. Question 9. We know what the what dy dx is. Let's find the antiderivative of that. So it's 1 plus 6x times, times 1 minus 6x with respect to x. So that means that my y is minus that function plus c. We know it goes through minus 1, 0. So let's go menu, 3, 1. Y is 0 when it's this plus c. We want to solve that for c, and we know that x is -1. So you get c is minus 11, and that matches option A. Let's look at question 10. It's an antiderivative between 2 and 3 of 2 times a times x plus 1 with respect to x. However, I see that a, you see how that's in bold? That's a variable, so I'm just going to put in b because I know I haven't defined b anywhere. And I know that that function equals 21. And I want to find the answer for b. So I'm going to do a solve this equation for b. I'm not going to solve for x because the x values are going to be put in from the terminals on that integral, and you get that b is equal to 4, or in this case a. I just didn't want to. Have a look at question 3 of the extended response. I'm going to define f of x as minus e to the x times by the cos of x. Find the exact values of any stationary points. So stationary points are where the derivative of f of x is equal to 0. So I'm going to find the derivative, copy that in. I'm going to find the derivative, I'm going to copy that in, and equals 0 for x. And we get that gives all the solutions. And then we look and say, hang on, we only want our x values between 0 and 2 pi. So I'm going to copy this down. Given that 0 less than or equal to x less than or equal to 2 pi. And if we do that, it gives the answers of pi on 4 and 5 pi on 4. So they're the exact values, x values of the stationary points. So to get the coordinates, I'm going to sub those values in. So I want to find f of pi on 4, and I want to find f of 5 pi on 4. Actually, I'll just copy this down, make that 5, and then I can just write those as coordinates. For each stationary point, state whether it is a maximum or a minimum. So I'm going to find a second derivative. So derivative with respect to x of the derivative I found up here. If x is pi on 4, I'll get an approximation. That second derivative is 3.1, which is greater than 0, so pi on 4 is a minimum. If I sub in 5 pi on 4, that value is negative, so it is a maximum. If I wanted to check that, I could draw it. F of x. There it is there. I have a minimum at pi on 4, and a maximum would be up the top here at 5 pi on 4. So that's really an easy 6 marks if you know how to use your calculator.